Hey everyone, welcome back to Start Early YouTube channel where we build your JEE and NEET foundation right from class 9th and 10th so that when 11th hits, you are already ahead of the curve. In our last two videos, we have covered classification of living organisms, taxonomic hierarchy, and binomial nomenclature. Today, we are switching to chemistry and we are starting with one of the most important topics, what is atom and how did scientists figure out what it actually looks like. This is honestly a detective story, one scientist after the another, each one finding the flaw in the previous theory and building a better one. Let's go into it. What is an atom? Before we talk about atomic models, we need to answer a very basic question. What is exactly atom? Look at the pencil in your hand. It's a matter. Table is a matter. You yourself are a matter. Now imagine you keep breaking the pencil in smaller and smaller parts. At the point, you will realize that it cannot be broken into a smaller part. So the of a formal definition of the atom is an atom is the smallest particle of an element that retains the chemical properties of that element. Let's see ये atom actually अंदर से कैसा दिखता है. Every atom has three type of particles: proton, neutron, electron. Proton is positively charged, sits inside the nucleus. Neutron, no charge, also sits inside the nucleus. Electron, negatively charged, orbits around the nucleus at a very high speed. So I feel you guys have now actually understood a basic idea of an atom. We will see further how a atom actually looks and how the electrons revolve around it. The nucleus is the center of the atom, tiny, dense, and positively charged. Electrons move around it at a distance. Here is the best analogy. Picture this. Imagine, okay? Now, nicely imagine this part. The atom is a massive football stadium. The nucleus, all the protons and neutrons, would be the size of a marble sitting at the center. And the rest of the stadium, yes, that's just empty space with electrons moving at the edges. So in front of us is now a atomic model that we use at present day. In between there is a nucleus contains neutrons and protons, and electrons are revolving around it. And it is a consequence of various failures, and the other scientists have rectified it to the present date model. So we are going to see the attempts of and models of various other scientists in the coming slides. So now let's see the atomic models given by different scientists. Dalton was the first person to give a proper scientific theory about atoms, and his model was very simple. He said that the atom is a solid, invisible sphere. So the main points of the Darwin theory were every element is made up of tiny particles called atoms. उसके बाद all the atoms of same element are identical, or atoms cannot be created, destroyed or divided. Atoms combine in fixed ratios to form compounds. ये चार पॉइंट जरूर याद कर लीजिएगा. These points are very important. Every element is made up of tiny particles called atoms. First point. Second is key. All atoms are made up of same element is made up of identical atoms. Third point is atoms cannot be created, destroyed, divided. ऐसे run करना है. Created, destroyed, divided. Atoms combined in fixed ratios to form compounds. Atoms combine in fixed ratios to form compounds. ये बार बार बोलोगे तो जरूर लर्न हो जाएगा. उसके बाद the limitations of this model was that questions arise in the minds of different scientists. If the atom is just a solid ball with nothing inside, where do electrons come from? Where does the charge come from? And how do reactions even happen? So, this limitations tells us that Dalton's theory was not able to predict or say the internal structure of an atom. So, to improvise this, many theories come ahead on the basis of this. But this was the first theory that gave the idea that atom actually exists and cannot be divided nor can be destroyed. So our next model is J.J. Thomson model. So this model is also called as plum pudding model. And in this model, the very significant thing here to notice is that he discovered the electron, and he basically assumed the atom to be a sphere of uniform positive charge. So here you can see a drawing of his uh, model that he assumed the atom to have positively charged, uniformly distributed throughout the atom, and the electrons are embedded inside like seeds in watermelon. So the red dots here are electrons. So he assumed that the entire atom is a uniformly distributed, positively charged, and the atoms are electrons are distributed within the positive charge of the atom. Hence, it looks like seeds in the watermelon. And this was also called as Plum coding model. The biggest limitation that this model holds is that it assumes the entire positive charge to be surrounded throughout the atom, but that's not reality. In reality, the positive charge is located in the center in the nucleus, and the electrons revolve around this charge in different orbits. So I hope you understand what I am drawing. That that nucleus is in the center and electrons are revolving around the nucleus. So that's the biggest limitation of this model. And yes, now let's move to the next model. So our next atomic model was given by Rutherford. So before giving the model, Rutherford did an experiment to get a proper understanding of what model he is going to get. So before understanding this experiment, we have to understand a simple concept that you will learn in the 11th or 12th in physics, that if two positive charges come towards each other, they will repel each other. Means if these two positive charges are taken towards each other and left, then they will apply a force towards the opposite side, right? And if two unlike charges, like one positive and the other negative, like these charges are brought closer, then they will show attraction force and they will come towards each other. Okay, so if you all have got this concept, then we will begin with this experiment. So, according to this experiment, Rutherford took a thin gold foil and bombarded very tiny, fast-moving particles called alpha particles towards the gold foil. Okay, and then based on the Thomson's model, he expected that all particles will pass through and go undeflected. But what actually happened stunned him also, that most of the particles went straight through as expected, but some particles deflected slightly. So some particles actually deflected slightly, and some even bounced back. Like very few even bounced back. Uh, very few bounced back, that was completely unexpected. So, why did this actually happen? We will see in the next slide. Now, let's check out on the last model, that is Bohr's model. And this is a very important model as it rectified the mistakes done in all the previous models. So, he also solved the biggest problem of the Rutherford's model, that Bohr said that electrons do not move randomly in their nucleus, they move in a specific fixed paths called orbitals or energy levels or shells. So he majorly gave postulates that are very important and are frequently asked in the exams. So the first postulate is that electrons revolve in the fixed orbits, and they are numbered as first, second, third, or KLM. So around the nucleus there are orbits serially arranged. So this is first orbit, this is second orbit, and this is third orbit. So the orbits are designated by the letter N, and they are numbered 1, 2, 3, 4, so onwards, and they can also be told as of K. So if you take the first as K, then K, L, M, N, and so on and so forth. So the first orbit is K, second is L, third is M. And the second postulate was that uh, no energy is emitted and absorbed while in the orbit and atom is stable. So the what was the limitation of Rutherford, that he did not specify that electrons do not emit energy, but Bohr did. And he said that electrons, while revolving around the nucleus, they do not emit any energy. Hence, atom is a so the third postulate is that when electrons jump from one orbit to other. Okay, so when electron jumps to a higher orbit, say this electron is now in first shell. Now if this electron jumps in the third shell, then it absorbs energy. So the postulate was that if one electron jumps to a higher orbit, it absorbs energy. And when a electron jumps to a lower orbit, say this is in third orbit, now if it jumps in a lower orbit, say first orbit, then it will emit energy or release energy. So this was its third postulate. And the fourth postulate here is that he gave a formula. The formula says mvr equals to nh by 2 pi. Just for now, remember this formula: mvr equals to nh by 2 pi, nh by 2 pi. So this is a very important formula, and frequently numericals are phrased on this. Here m is the mass of electron, m equals to mass of electron, v is the velocity of electron in the orbit, r is the radius of the orbit, so this is the radius of the orbit, and n is the number orbit. So for this electron, if we write, the orbit number is 1, and h is Planck's constant, and it has a fixed value that you will remember when you come to higher classes, or I will tell you now only. The value of Planck's constant is 6.6 into 10 raised to minus 34. I repeat, Planck's constant's value is 6.6 into 10 raised to minus 34, and upon 2 pi. So pi value, I hope you all know that pi equals to 3.14 or 22 by 7. And the mass of electron is also fixed here, that is 9.1 into 10 raised to minus 31. 9.1 into 10 raised to minus 31. So try to remember the value of mass of electron and Planck's constant. This will help you ahead, or else you can, when you come in 11th and 12th, you will learn in every single chapter or other. So yes, but this model also had some limitations. That limitations of Bohr's model were, this model was only applicable to single electron species or hydrogen atom species, and this model did not did not account for wave nature of the electrons. So Bohr's model took into account only particle nature. Okay, this point is not mentioned, but remember this, that Bohr's model took into consideration only particle nature of the matter, but not the wave nature of the matter. So you can remember two limitations of Bohr model for now: that it was only applicable for single electron species. This was only applicable to single electron species, or only hydrogen atom. And a second limitation is that it was not applicable for wave nature of electrons. It took into consideration only particle nature of electrons. Now let's have a quick revision of whatever we have studied today. So we have studied four models given by four different scientists. They were Dalton, Thomson, Rutherford, and Bohr. So this is the year of the discovery in which they give their model. They gave their model. So you do not exactly need to remember the years. Just remember the timeline. That first Dalton, then Thomson, then Rutherford, and then Bohr. So you just need to remember the sequence of their discoveries. So the first is Dalton. The model name is solid sphere. The key feature of this is atom is indivisible, and the flaw means the main drawback of this theory was it didn't give any internal structure. It didn't define any electrons. So second is Thomson's model was plum pudding model or watermelon model. So the key idea was he discovered electrons, and actually defined the electrons in the positive sphere. But the main drawback here was that it didn't define nucleus. It only said that the positive charge is uniformly distributed throughout the sphere. The third one is Rutherford. So it gave a planetary or nuclear model. The nucleus is at center, and electrons orbit around it. but it couldn't explain the stability. I hope you guys remember that he couldn't explain the stability as when electrons move in the orbit, they will emit energy and will fall in nucleus. But atoms are stable, so this model could not explain the stability of the atom. The last and the fourth model was Bohr's model, and it gave four postulates. It fixed the orbits and energy levels, but the flaw is that it is only applicable for single electron species or only hydrogen atom. And one more flaw we studied extra. It is there in needs portion. It's not like extra, but the flaw is that it doesn't define wave nature of particle. It only proves the particle nature of any matter. So do take a screenshot of this table. This table is very important as theoretical questions can be framed from this table also. NEET PYQ previous year question. So the question says that Rutherford's alpha particle scattering experiment was responsible for discovery of. So if you don't know the answer of this question, then go back, watch this video again because the answer to the question is in the video only, and then attempt it, or else take a pause and then answer the question. So Rutherford's alpha particle scattering experiment was responsible for discovery of. See, we saw Rutherford's experiment where he took a gold foil and bombarded alpha particles, and some deflected and some did not. So what it actually proved that the alpha particles, the very few alpha particles that rebounded, that deflected to a much greater extent than he expected. So that showed him that a greater positive charge is concentrated in a small space, and that small space was later called as atomic nucleus. So the correct answer for this question will be atomic nucleus. Thank you. So, like this video if you are genuinely helped from this video, and please subscribe to my channel and comment your doubts in the comment section. In the next video of chemistry, we will try to cover atomic number, mass, isotopes, isobars, and especially electronic configuration. That is very important. That is the basic to the entire chemistry of 11th and 12th. So, please subscribe to my channel. I will see you in the next one. Thank you. Bye bye.